Hi, everyone. Welcome back to another episode of AWS Supports You. My name is Clint Wyckoff, and I'm an enterprise support manager based out of Pittsburgh, Pennsylvania, and I'm going to be the show host today. AWS Supports You brings experts from AWS Enterprise Support, as well as our solution architecture organization, and we aim to help customers like yourselves optimize performance in the cloud, lower costs, and provide you with best practices as well as design considerations. So joining me today on AWS Supports You is Louise from our support organization, as well as Thomas from our solution architecture team. Let's start with you, Louise. Why don't you go ahead and give us a quick introduction?
Sure, thanks, Clint. Hi, everybody. My name is Louise, and I'm a technical account manager based in Amsterdam in the Netherlands. And I support customers in the Benelux region with sustainability projects and questions and things like that. So really excited to be here today. Over to you, Thomas.
Waiting for that. So hi, everyone. I'm Thomas Attree. I'm a solutions architect based in London. And I primarily support customers in the UK power and utilities industry.
Cool. Well, thanks, Louise and Thomas, for joining us today. The topic of today's AWS Supports You is making sustainable decisions in the cloud, which is very important. And I think the interesting piece with this topic, Louise and Thomas, is just making folks aware that just even though they're running in the cloud, there's still things and efforts, initiatives taking place behind the scenes that AWS is conducting, as well as that customers on their behalf, customers can go on their own to make sustainable decisions as they're choosing like instance types and things of that nature that we'll talk about today. Before we get to the content at hand in the presentation, a quick note to the attendees online. First of all, thanks for taking a few minutes to join the stream today. If you come up with any questions, comments, anything like that, we want to keep it interactive. Feel free to throw in the chat where you're joining us from today. Thomas and Louise will be answering questions periodically as we go through. The second thing is, if you'd like to have your topic or have your voice heard within AWS Supports You, we're going to throw a link to our survey here in the chat in a second. Please head out there. Who knows, maybe one of your comments or pieces of feedback might result in a future episode here at AWS Supports You. But now that we have sort of the administrative details out of the way there, Louise, can you give us a quick run through of what we're going to be talking about today?
Yeah, sure, Clint. So actually, to get started, this is actually our first talk of 4. So we're doing kind of a sustainable awareness month within AWS. And the first talk we're doing today is making sustainable decisions in the cloud, myself and Thomas. Next week is going to be optimizing your AWS architectures for sustainability. So here we're going to be focusing mainly on your compute, storage, and networking workloads. Then the third week is going to be optimizing for artificial intelligence and machine learning for sustainability workloads. And then the last one is going to be sustainability through the cloud and also optimizing for your Internet of Things workloads as well. So they'll all be recorded, but if you'd like to join any, please feel free to. And also, if there's anything that you'd like to see apart from this, just let us know in the chat and we can add it to one of the presentations as well. But yeah, so to get started in what we're going to be talking about today. So the agenda for today basically is, first, Thomas is going to be walking you through the sustainability shared responsibility model. So basically, in terms of sustainability, what are you responsible for and what is AWS responsible for when it comes to your architecture in the cloud? Amazon's renewable energy commitments, so the climate pledge, what we're doing there and what you can kind of gain from it. The customer carbon footprint tool, so this is a tool that we have to calculate your carbon, your CO2 emissions. And then the sustainability well-architected pillar. So I'll be explaining what this is and going through some best practices and design principles. Then the improvement process, so how you can improve on your workloads within AWS, and lastly, call to action. So yeah, without further ado, Thomas, do you want to take it away?
Thanks, Louise. Yeah, sure. So when I talk to customers about sustainability at AWS, it becomes very apparent that people are very, very aware of the situation we're in on the planet right now, right? The global temperature has risen a degree since pre-industrial times, and we're already starting to see the impact of that with things like rising sea levels and more unpredictable weather events, such as wildfires in the US, really hot summers and heat waves in Europe, as we've been encountering in the last few weeks. And I think, instead of boring you with the facts of climate change that I think you hopefully are aware of already, I like to present this quote by Robert Swan, who was the first person to walk to both the North and South Poles. And he said that the greatest threat to our planet is the belief that someone else will save it. And what I really like about this quote is that it really hammers home that it's everyone's responsibility to take their step in terms of decarbonising the planet and ensuring that we've got a future home to live on for future generations. And it leads me on really nicely to what I want to kind of cover next, is that sustainability is a shared responsibility, not just at home, but when you or in your peers at day-to-day life, but especially in the cloud. And where have we seen this before? Well, if you're a regular viewer of AWS Supports You, you're probably familiar with the AWS security responsibility model. And what the security responsibility model really lays out is where the demarcation points are between AWS and AWS customers when it comes to security. So that might be the way that you protect your customer data, the way that you manage identities to administer your applications, the way that you set up firewalls, for example, with your applications in the cloud. And then on the flip side of that, on the orange section of the slide, is AWS's responsibility. So how we secure our data centers, how we secure the APIs that you interact with. So you probably sat there thinking, why show me a security responsibility model, Tom? This is a sustainability talk, and you're right, it is. But what we can do is introduce that same model with sustainability on the cloud as well. So what we have here in the blue is the customer's responsibility for their sustainability in the cloud, and in green is AWS's responsibility for the sustainability of the cloud itself. And I'll go through just a few highlights for AWS's responsibility of the cloud next. So back in 2019, together with Global Optimism, the Amazon, not just AWS, but Amazon as a whole, founded the Climate Pledge. The Climate Pledge, the goal of the Climate Pledge is to achieve the Paris Agreement goals 10 years early. So through regular reporting and continued investment, we now have over 300 signatories, so 300 different companies and organizations around the world signed up to the Climate Pledge. AWS and Amazon have recently announced an additional 37 renewable energy projects across the globe as well. So that brings our total renewable energy project count up to 310 across 19 countries worldwide. And I think that takes our nameplate generation capacity once those projects come online up to 15.7 gigawatts. So it's a huge amount of energy that AWS has invested in the production of those projects and those assets to produce that renewable energy to put that back into the grid. And it complements the fact that Amazon are the world's largest corporate purchaser of renewable energy. And then the last point I wanted to highlight on this slide was around the Amazon Sustainability Data Initiative. And the ASDI, that provides access for customers to real key data sets that they can use within their sustainability projects. So you can find climate forecast models, for example, within the ASDI from organizations such as NOAA or the UK Met Office. And those data sets are hosted for free by AWS. So what can a customer do in the cloud? I'll hand over to Louise.
Great, thanks, Thomas. So yeah, on the next slide, we're going to be touching on the well-architected pillar, I believe.
Yep.
Great. I was right. So just before we get started into that, we're going to be touching on basically what actually is sustainability. So yeah, so we've all heard it. You're probably hearing it more recently than ever, as it's becoming such an important kind of issue basically in so many different aspects, so social, economic, and environmental. And today, with the sustainability in the cloud topic, we're going to be focusing on the environmental impact of this pillar. So especially energy consumption and efficiency, as this is probably the most important for architects to know and to improve whenever they're building on the cloud, for reducing resource usage as well. So as it says here, sustainability in the cloud is a continuous focused effort on energy reduction and efficiency across all components of a workload. So we often get questions from customers, people like myself and Thomas, so technical account managers, solution architects, basically like questions like, how can I sustainably optimize my current workloads on the cloud? Or how is moving to the cloud more eco-friendly? I don't have a data center, how can I contribute, that kind of thing. So we're hoping that the point of this presentation is basically to kind of touch on some of these points and answer some of these questions for you. So moving on to the well-architected framework, what exactly is it? So basically, it helps you understand kind of the pros and cons of decisions. So whenever you're building systems or workloads within AWS on the cloud, it describes key concepts, design principles, architectural best practices, so that you can design and run workloads in an optimal way. So we would be asking you kind of foundational questions, helping you understand your architecture and seeing how it aligns with the cloud best practices, and gain guidance for then making improvements basically. So we give you some kind of action plan, and from there we decide how you can best improve. So the pillars are operational excellence, security, reliability, performance, efficiency, cost optimization, and the last one, which was just introduced at the last reInvent in December, is sustainability. So that's what we're going to be touching on today, obviously, given the presentation. So we want to just give you best practices and design principles on how to make your architecture as sustainable as possible. And to do that, so here are 3 parts from the pillars. So one is understand environmental impacts of the services that you're using. 2 is quantify impacts through the entire workload lifecycle. And then 3 is apply best practices to reduce these impacts. So touching on some of the best practices here from the pillar first. So the first here is user patterns. So basically, user behavior patterns can help you identify improvements to meet your sustainability goals. So for example, we would be asking our customers questions like, how are your users using your workload? Where are they located? When do they use it? And this kind of helps you drive decisions on your architecture. So for example, if you are, I actually have had a customer where they were running EC2 instances and running workloads on weekdays only and then not on weekends. So from there, we were able to see that they could, instead of having all of these underutilized resources, they could scale infrastructure down when it was not needed. They could position resources to limit the amount of network required for users to consume them as well, remove any unused assets. So here we were able to suggest using spot instances or EC2 instance schedulers so that they would only run when they need to run. And I was also able to take a look at their cost and usage reports to get an idea of how they were actually using the services, and then from there make decisions of how we could best optimize their usage there. So that's kind of one example. Another then is implement software and architecture patterns. So basically perform load smoothing and maintain consistent high utilization of any deployed resources. So understanding the performance of your workload components and optimize the components that consume the most resources. So if you're using a programming language, how have you architected that code? Could it be optimized? Which areas of code consume the most resources? So moving on to hardware. So so basically analyzing hardware patterns to identify any opportunities that reduce workload sustainability impacts. So here you can, minimize the amount of hardware that's needed to provision and deploy. I always recommend to my customers to select the most efficient hardware for your individual workload. So an example here is, picking the right hardware for what you're trying to achieve. I had a customer that was running workloads over multiple EC2 instances before, and I actually recommended them to start using Graviton 2, which was at the time our most powerful, most efficient instance, basically. So it was a really powerful processor. I think it was 2 to 3.5 times better CPU performance than any other processor that we actually had, and also better price performance. So they ended up moving to Graviton 2, and they saved on cost, and performance was a lot better, and also they were being more sustainable. And now that Graviton 3 has recently been announced, this processor actually uses 60% less energy for the exact same performance. So I've started recommending Graviton 3 to my customers now. For data, so analyzing data patterns to implement data management practices that reduce the provisioned storage, so required to support your workloads. So an example here in terms of storage is using S3 lifecycle capabilities, so moving your data to more efficient, less performant storage when requirements for it decrease. So for example, if you have a data requirement where the data can actually be archived, archival storage uses a lot less hardware, and it's also less accessible as well. So it is more sustainable. Also, deleting data as well that's no longer required not only saves you on cost, but also, again, more sustainable. And then lastly, development and deployment process. So in your development and deployment process, identifying any opportunities to reduce your sustainability impact by making changes such as updating systems to gain performance efficiencies and manage any sustainability impacts as well. So using automation, for example, to manage the life cycle of your deployment and test environments, and using any managed device farms as well for testing would be another option too. So basically, seeing how you're actually utilizing your build environments. Before we move on from best practices, Thomas, if you're back, do you have anything you'd like to add?
Yeah, I should be back now. Sorry about that technical gremlin there with the sound. But the point I wanted to make under the software and architecture best practice was around cron jobs, and put in the chat if you've ever written a cron job before that's triggered on the hour or at midnight, for example. But one of the best practices there is to introduce a bit of jitter to those scheduled jobs and those batch tasks. And the reason for that is if you consider all of our customers are guilty mostly of writing cron jobs that start on the hour. From a very historical point, we've all done it. I've done it in the past. But actually, when you think about the amount of underlying hardware that we have to provision and make available to deal with that peak load during the middle of the night or on each hour, it's quite considerable, which then is underutilized for the rest of that time when that job is not running. So something to consider when looking at your software and architecture patterns for your workloads.
Great, thank you. So before we move on to the improvement process, actually, is there any questions from the audience, Clint?
Yeah, thanks, Louise and Thomas. I threw out there in the chat, Tom, asking folks if they've ever scheduled a cron job before. And more specifically, have you ever scheduled a cron job in AWS? And for bonus points, who can tell us what AWS service you use to schedule a cron job? That's bonus points. Congratulations to I'm Iberian on passing the SA Associate, the Solutions Architect Associate exam. Maybe you know which service to use to schedule a cron job. But the one thing that I wanted to highlight here, and I think whenever you talk about sustainability, Louise, people might not necessarily realize that as customers and consumers of the cloud, they're actually contributing to AWS being more sustainable for all customers. Like, so for example, there you mentioned implementing Graviton or using getting a better price for performance, consuming less energy, being better stewards of the environment, things like that. And then there's also benefits that they get from a customer perspective as well, with cost savings and the better performance, utilizing Spot, for example, right? So being able to utilize the excess capacity that we have inside of a data center, like those are all things that customers can do to help contribute to sustainability. So, yep, go ahead with somebody again. Yep.
No, you're absolutely right, Clint. They are all things to consider, and I think we'll talk a little bit more about some of the requirements and the trade-offs that you make in a few slides' time as well.
Yeah, so we don't necessarily have any questions from the audience at this point. I'll flip it around and ask the audience and throw in the chat there. Besides, if you've ever scheduled a cron job before, whenever you're making decisions, whether it be on premises in an environment that you have there, or if it's in the cloud within AWS, is sustainability something that you think about? Like, lots of large enterprise organizations have sustainability sort of initiatives that they're underway, and they want to, reduce the carbon footprint and things of that nature. But is that actually something that you go through as part of your thought process on a daily basis? And actually, we did have a question here from the Spec 007. Hi there. Quick question. Is there any AWS sustainable review service?
Hi, thanks so much for the question. So we just went through some of the well-architected pillar, basically, and that has the sustainability pillar within it, where we do kind of review your architecture to see how sustainable it is and give guidance and best practices there. We don't have a specific, I would say, AWS sustainable review service yet, anyway, at least. But I guess that might be a good idea. But we do have a lot of services that kind of help you actually review how sustainable your architecture is. So we could also have Trust Advisor. This is a free tool, and it has some checks in it that you could utilize. For example, there's one to see if your resources are being underutilized or underused. So anything with under 10%, it will flag this. It will send you notification with the resource ID, and then you can go and check if it should be deleted or if it should be scaled down. So that's another way. And I also mentioned already the cost and usage reports. So in the AWS console, so you could check there your service usage, see what's being used, per region or per account, and whether it needs to be used or not. And that's another way you could consider to scale down or delete anything there too. So there's some options. Thomas, do you have anything else to add?
Yeah, maybe considering the customer carbon footprint tool as well, which will give you an overview of your CO2 output. But we don't have a tool, as Louise says, that's specific to reviewing in a minute. The closest thing would be the well-architected tool, which I think we're going to shortly cover.
Yep, exactly. Actually, that's a good transition. Any more questions, Clint?
No, that's all for now, Louise. Thomas, back to you.
Perfect. Okay, so we're going to move on from the well-architected pillar that we just mentioned to the improvement process and actually how that kind of works. So you can see here, basically it's an architectural improvement process, and it involves understanding what you have and then what you can do to improve. So selecting targets for improvement, testing improvements, adopting successful improvements, and then quantifying your success. We'll say how sustainable it is, and then sharing what you've learned so that it can be replicated elsewhere, and then again just repeating the cycle. So the goals of your improvements could be something like to eliminate waste, low utilization, or any idle or unused resources, or it could be to maximize the value of the resources that you consume. So just to give you, I guess, an example to kind of go through this. So let's just say that you do have a company that has a workload that performs complex image manipulations on EC2 instances, and then it stores that modified and the original files for user access. So the processing activities are very CPU intensive, and the output files are extremely large. What can you do to be more sustainable, to optimize for sustainability and to improve this, basically. So the first is identifying targets for improvement. This is where you'd review your workloads, whether they're large deployments or if they're just frequently used resources, which we call hotspots, and then look for opportunities to improve the effective utilization of those resources and to reduce the total resources as well, but still achieve your business outcomes. So just applying the example that we just mentioned, this could be using minimum amount of hardware to meet your needs, so scaling down on the amount of hardware that you're actually using, and then also using technology that best supports the data access and the storage patterns for the compression part. So next step is evaluating specific improvements. This is basically looking for potential improvements, estimating their potential impact, the cost to implement them, and the associated risks as well, and just making sure you're making the right decision. So you can also measure improvements over time and see how resources are actually being used. So again, just going back to the example, using the minimum amount of hardware to meet your needs. For here, you could do something like predictive scheduling to reduce the amount of CPU hours that are consumed by underutilized or underused resources, or unused resources. And then for use technology that best supports your data access and storage patterns, you could implement more effective compression strategies. So then moving to prioritize and plan improvements. So here you can prioritize what you've just identified as an improvement from the previous step based on the greatest impact, lowest cost, and acceptable risk, and then establish a plan for implementing and testing. So again, with the example, so based on the kind of high potential, the low risk or low cost, and low risk as well of updating the file compression, we would make this probably the number one prioritization. So make this the high value target, and then you'd add predictive scaling to the backlog and do that 1 second once you're happy with the first. Then test and validate improvements. So this is the experimentation stage where you'd be implementing the changes in your test environment and validate their potential for improvement. So if you're happy with it, then it's good to go. Otherwise, feel free to test it a bit more. And to be even more sustainable, you could perform small tests with minimized investment to reduce the risk of a large-scale effort as well. So just going back to the example, testing the storage required for both the original image and also the modified compressed image, and see if there was an improved reduction in the storage resources. Next is deploy changes to production. So implementing the changes across all production environments. So here you would test this out first in the production using limited deployment through a blue-green deployment mechanism, because again, just to be sustainable. And then when you're happy with it, go full deployment. And lastly, measure results and replicate successes. So this is where you revert changes if you're not happy with it, or else spread the word, look for opportunities to replicate the successes across all of your workloads. Just basically take what you learned, establish standards, and apply basically whenever you're happy with it, and other systems will hopefully benefit from it as well. So moving on to the next slide, I think we're going to be, Thomas is going to talk you through the metrics here.
Yeah, sure. So Louise spoke a little bit more about setting goals and KPIs there, and KPIs inform you of what you're of how well you're achieving a particular goal, but you need to define some metrics in order to inform that KPI. But metrics can be difficult to identify, right? And they can also overlap. So you can look at resources such as compute, such as storage, such as data transfer, but it's really important from a sustainability perspective, not just to optimize for one of them. So for example, if you're storing a data set only in one region and you're saving in storage resources, but are you increasing the amount of data transfer that you're forcing with that model to support customers that might be elsewhere in the globe? Or can you reduce the compute if you cache and store more results for longer periods? So an example here might be a video hosting website service that you have. And when you upload a video to that site, it generates a thumbnail and it stores that thumbnail. Maybe it stores it in Amazon S3. So we've got a little bit of compute when we're generating that thumbnail, and we've got a bit of storage when that gets stored. If that video then never gets played, or gets played only very, very rarely, does it make sense to store that thumbnail indefinitely on storage if it's never going to be, or very rarely and frequently, retrieved? Or does it make more sense to generate that thumbnail on the fly when the content is requested? I don't know. It's a trade-off, and it's very specific to the application. And it's why it's important to look at the user behaviors, as Louise explained, as part of the best practices of the pillar as well. But the trade-offs extend, and they extend past the functional metrics that we can capture, and the non-functional requirements of the application might compete with one another as well. So you've got to consider things like cost, moving processing work off of end user devices, because doing it on an end user device, for example, is usually more power hungry than it can be in the cloud. You might be able to increase the cost of that application because you're, now putting that processing into your cloud-based application rather than the end user device, but you're improving the overall sustainability of the application itself, because that smartphone from last year or from 3 or 4 years ago with that really inefficient processor architecture is now not performing that compute as well. So it's about looking at holistically the whole picture as well. Things like utilization and availability can often compete with one another as well. So if I consider an EC2-based workload spread across 3 availability zones, now in order to maintain availability and redundancy across those 3 servers in availability zones A, B, and C, if I was to lose 2 availability zones, if that's what I'm preventing against, then I have to have a 30% level of utilization maximum across those EC2 instances, so that I can lose 2 and that one instance can still cope with the load that I've lost. Now, this is not architectural best practice. This is a hypothetical question that we're going through right now. But if we move that 3 availability zones spanning application to 2 availability zones, now, if we are looking at protecting ourselves against losing just one of those availability zones, we can raise our average utilization up to 50%. Because if we lose that other server in availability zone B, for example, that workload can safely be accommodated by the server in availability zone A. So depending on the application, depending on how your users are using it, and other non-functional requirements such as time to recovery, for example, really, as an SA and working and supporting customers going through these trade-offs, it really does depend on the type of application that you're running. And it's important when looking at how you're operating your workload from a sustainability perspective, or how you want to optimize your workload from a sustainability perspective, not just to focus on the resources that you're using. If you have a decreasing user base, but your utilization remains the same, then that's a cause for alarm. What we actually have to do here is factor in some business metrics as well to measure the efficiencies in the resources unit of work. So we take a resource, maybe that's an S3 bucket, maybe that's an EC2, maybe it's much more complicated than that and compound resources built up of different AWS services. But we divide that by a unit of work. So that might be how much vCPU does it take to serve this particular type of API request? Or how much data is returned with this type of database query that gets frequently called for? Or how many megabytes of data are we storing per customer? By breaking it down by a unit of work, that's where we can really start to then further optimize for that particular element. And before I hand over to Louise to go into how we can measure against those goals and KPIs and bring those metrics in, I think we're going to stop here for a few more questions if any have come into the chat, Clint.
Yeah, so we did have a question. You sort of you touched on it a little bit whenever you were discussing metrics, Thomas, but the question from I'm Liberian is, Can CloudWatch metrics be considered a sustainability feature?
I wouldn't say a feature, but they can definitely be used to inform against utilization. Absolutely. And I'm actually going to show a architecture diagram in a couple of slides' time as to how that can be used. So yeah, that's a really good question, and yeah, can absolutely be brought in and thought about as being an informing metric for sustainability.
Awesome. Well, then let's get after that, because there's no other questions for the time being. However, folks online, if you do think of any questions or anything that you'd like Louise and Thomas, please feel free to add those to the chat, and we'll get them answered for you live.
Great, thank you. So one of the first tools we have for measuring, Thomas already touched on it briefly, is the customer carbon footprint tool. So this was only just released back in March, so it's quite new still. And basically what it does is it provides customers with an AWS customer carbon footprint. So we kind of help customers understand the carbon footprint of their workloads running on AWS, and also knowing the carbon emissions associated with their use of the AWS services. To help with, reporting, things like that. So it's very handy for tracking your progress and analyzing the changes in your emissions over time. If you're migrating your workloads to AWS, or re-architecting applications, or deprecating unused resources, it could be used for any of these things. But it could also be used if you are planning for the future. So, if you want to forecast how your emissions will change across your sustainability journey, or plan for any future deployment strategies, it's a great tool for that kind of thing. Just as a quick kind of case study, I'm sure a lot of you have heard of Starbucks. So Starbucks used or applied basically the AWS best practices to their workloads. So, and they saw from 2019 to 2020, the actual carbon footprint of their AWS workloads was reduced by approximately 32%. Despite tremendous growth during that actual same time, they managed to completely reduce their carbon footprint, which is just amazing. And this was through setting sustainability proxy metrics based on service usage, as kind of demonstrated from the well-architected lab for sustainability that we were talking about before, and also using the AWS carbon footprint tool as well to help gather data from their historic data, actually is what they did, and then use that to help the team drive reductions. So yeah, the tool is really handy. It's in the billing dashboard within the AWS console if anybody wants to check it out. And it indicates, a systems of carbon footprint for different quarters, things like that. One thing to be aware of, though, is that the data that you see in the tool is 3 months delayed, because this is down to the time it takes to actually collect and process the carbon intensity data from our energy partners. So we have another way as well of calculating, which, if you'd like to touch more on, Thomas.
Yeah, of course. So as Louise said, the customer carbon footprint tool is really good at reporting on your megaton equivalent of CO2 emission. But because of the delay, it's not the best tool right now to use for making operational decisions on your workloads. So for those, we need to rely on what we call proxy metrics. And there are things that we know are good practice for sustainability at AWS. And we can start to make directionally correct decisions between them. So that might towards them. So that might be things like adopting Graviton, as Louise mentioned before. It might be adopting managed services where the overall utilization of the hardware is managed by AWS rather than responsibility of the customer. So when thinking about proxy metrics in this way to make directionally correct decisions, we want to report on that a little bit faster than we can see the actual megaton equivalent CO2 release from the customer carbon footprint tool. And there are already two great sources of information. One I've touched on by answering the question in the chat earlier, but we have the cost and usage reports in AWS. And so where utilization of a resource is really closely tied to its billing model, such as S3, for example, your billed per gigabyte or megabyte of data stored, where where the utilization of a resource is directly comparable to the way it's billed in the billing model, we can use the cost and usage reports. Now, that doesn't work very well for services like EC2, where if you have a EC2 instance sitting there at 2% utilization, you build the same regardless of whether you've got it running at 2% or you've got it running at 100%. So for those kind of resources, that's where we may need to rely on metrics that we can gather from Amazon CloudWatch. Now, what we can do is combine both of these metrics into Amazon S3. We can then query those metrics with Amazon Athena directly on the data that's stored in that S3 bucket. And we can start to apply our assumptions on what good is for our workloads in AWS. So, like I say, if we know that Graviton-based workloads are more efficient, then we can give ourselves a better score for those Graviton-based workloads where they exist. And we can give ourselves a more negative score if we have workloads that are based on or built on older instance types on EC2, for example. Once we have those queries written in Athena, we can then dashboard those really quite nicely in Amazon QuickSight. And that's where we can start to track our improvements over time as well with some of the time-based graphs that QuickSight can give us. And we actually have customers doing this today. So Scania, the heavy truck manufacturer, during an internal hackathon, they developed a set of sustainability KPIs down to the application level. And the team then worked with AWS to determine how those KPIs could be measured through AWS usage reports and service metrics, alongside their own business data. And they built QuickSight dashboards to inform them. And then ultimately, Scania are looking to create that as an efficiency rating for Scania IT solutions. So every application will then be scored based on the assumptions that they've made and the metrics that they've got in to feed those KPIs. Really, their ultimate goal is to enable the most sustainable IT system possible. And at AWS, we're supporting customers kickstarting their journey into this, into data collection and analysis by developing an AWS well-architected lab. And this guides you through the process of turning cost and usage reports into efficiency reports. So you can go and do this lab right now in your own time. And by completing that lab, you're going to be collecting your cost and usage data. If you don't have any cost and usage report data right now, that's fine. It'll walk you through how to set that up. Or you can use some dummy data that we've got in there for you as well. We'll load that data into Athena, and we'll be able to query it and create proxy metrics for sustainability to create efficiency scores. Once you've got that set up, that's when you can then go through the improvement process that Louise went through and start to see the changes happen in near real time, especially if it's a QuickSight metric that's informing your KPI. And I forgot the slides there, but the Scania, the workload there, and also the well-architected lab, who I think Clint has put the link into the chat there for you as well to see. So, as a bit of a call to action for all of you builders on the stream, start thinking about sustainability as that additional non-functional requirement. Design your IT sustainably. It really can help the rest of your company decarbonize quite quickly. IT generally is quite a large user of energy within businesses. And the sooner you can move to more sustainable workloads, making use of sustainable services within AWS helps everyone. It's everyone's responsibility, as I touched on at the beginning. Have a look at different areas where you can make the biggest difference. So, there are costs and trade-offs to making changes to applications for sustainability. Weigh them up. Can you move to a Graviton-based instance with an ARM-based processor? Maybe, maybe it's a little bit more work that will take a little bit longer, and the benefit isn't as clear as maybe doing something like S3 data lifecycling and just deleting stuff after you don't need it. So that prioritization mechanism as well. And talk about what you find. Come and talk to us. Come talk to your AWS account team and tell us what you've learned, how you are optimizing your workloads for sustainability as well. We really like to hear customer stories and also help you on your own journeys too. So I think that's the end of our of what we wanted to cover for you today. Next week, there is optimizing for AWS architectures for sustainability, where Louise will deep dive with a colleague Katya will deep dive into specific strategies for optimizing AWS architecture for compute, storage, and networking. So really encourage you to join that one as a bit of a sustainability month for AWS Supports You takeover. But if we've got time, Clint, if there's any more questions, then we can take them.
So, Louise, Thomas, that's a fantastic presentation. There's no more questions that we've come across in the chat yet. But I thought maybe just have a few minutes of back and forth because, you know, from my perspective, if you look at some of the things that you mentioned there earlier, like Spot, you also mentioned the EC2 instance scheduler, going through the well-architected tool, identifying areas or workloads that might be a good fit for Graviton. You mentioned S3 lifecycle management. All of these are typical recommendations that we make to customers for better usage and being better like cost optimized or architected in the cloud. Would you sort of agree with that statement?
Absolutely.
Yeah, it's generally around utilization, right? And wherever you can push that utilization to AWS, where we can do it at a scale that individual customers just simply can't, that generally has a better impact on sustainability. So moving to serverless is a great one, right? If you are running compute workloads on EC2, there is always an idle overhead, unless you have developed a really clever way of just absolutely maxing out your EC2 instances all of the time. Whereas moving that compute to serverless function like Lambda, the overall utilization of the underlying resources, so I'm not talking about instances here, I'm talking about the physical servers, that's managed by us. So the way that we schedule and manage those jobs across all our server estate, that responsibility lies to us. So back to the shared responsibility model, it shifts down to AWS, and we can manage that at such a scale in which it's off of your hands, but we can also do it a lot more efficiently.
Yeah, for sure. The economies of scale that we offer and taking the load off of customers, so you don't have to necessarily, or the customer doesn't necessarily have to worry about, you know, starting or stopping your instances, or, you know, which platform does it run on. Like, utilize serverless technologies like Thomas mentioned there, or utilize managed services like RDS is another example in the database world. We did have another question that came across from the Spec 007. This is their second question. Thanks for that. Why is it more sustainable to move your data to archival storage?
Sure, yeah, I can take this one if
sure,
you want to, Louise, or
I don't think it's fine.
Okay, so life cycling data through storage tiers, especially on S3, is quite important. The most important thing is thinking about, do you even need that data anymore? I've come across a lot of customers that, you know, when we've really dug into it, they're storing CloudWatch logs from 2 years ago. You're like, you don't need this. You're not going to be querying these operational logs for a release that's 2 years old on your application. But back to the S3 example, by life cycling data through to colder storage tiers, essentially means, you know, we can have disks that are storing that data that aren't powered on all the time. So hot storage that's very available instantly has to be powered all of the time for a customer to be able to retrieve that data. When we start moving to storage tiers like Glacier, where you have a delay in the time of you requesting the data and us being able to serve it, that's when we can actually have banks of hardware that's not on all the time. The data's there, but we can turn that hardware on once that request has been scheduled to be served. And so moving to those colder storage tiers essentially just means there's less energy going through the hardware required to serve that data.
So less physical resources being used as well, which is another more sustainable, and it's actually more optimized for cost as well, which is another just win on the side. We're going to be touching on this actually a lot next week. We're going to be doing optimize your architecture for sustainability workloads, but focusing on storage as well as compute and networking. So if you are interested in learning more about best practices in terms of sustainability for storage, tune in next week.
Yeah, and I think the interesting conversation to have there with customers and to help them understand is that they need to have a solid understanding of the access patterns of their data to realize what needs to be on warm or hot storage, readily accessible, or what can I offload to colder tier storage, or maybe I have a longer retrieval time. And my experience as a TAM is that customers don't always understand what the access patterns of their data are like. So Louise, is there any, just a quick maybe primer for next week, are there any services that customers that we might have that might automatically tier their storage for them?
S3 with the lifecycle policies. So that's actually a really good way, because if you have a lot of storage and, trying to manually move it to different storage tiers or trying to archive it after a certain amount of time, you can make use of S3 lifecycle policies, which will automatically do this for you depending on whatever parameters you set up. So it's a much more easier way to just actually have control of your data and decide what kind of requirements, or like where it should go, or if it should even be deleted after a certain number of days or months. Also things like compressing the data into different formats. Certain formats are more sustainable than others. I don't want to give too much away of next week's presentation, but yeah, we'll be talking about all of that kind of stuff.
Awesome. Just trying to get a little cliffhanger for folks to, because we are here at 2 p.m. Eastern every single Monday. So be sure to mark your calendars and join us back on another episode of AWS Supports You. So for today, we covered a lot of different topics around the realm of sustainability, sort of the primer for the month, leading into more advanced talks over the next couple of weeks. We talked about the Amazon Sustainability Data Initiative. We talked about the well-architected tool, the well-architected labs that you can go through, setting up QuickSight dashboards so that you can sort of monitor your cost and usage data there. All super important stuff that Louise and Thomas covered. So if you do have any questions that you think of after the fact, my ask of the attendees online is to head over to repost.aws and you can ask your questions there live. And we have experts like Louise and Thomas standing by to answer your questions. And who knows, maybe a question you ask on Repost might end up in a future episode of AWS Supports You. Alternatively, you can send us an email. And our email address is awssupportsyou@amazon.com. As I mentioned, we're here every single Monday, 2 p.m., 11 a.m. Pacific Standard Time. And next week's topic is going to be optimizing your AWS architectures for sustainability. Thomas, Louise, any closing remarks before we call it a day?
Thanks so much for listening.
Thanks for listening.
Fantastic. And attendees, happy cloud computing.